Hey guys, in this video I will be continuing on with graphical display. So this is exercise 9B, I think it is, in the textbook. Basically we'll be going a bit more over some of the graphs that we looked at last lesson, so how to draw them up and what their physical structure kind of looks like, talking about appropriate axes, that sort of thing. Alright, so yesterday we looked at frequency tables and we've got notes on this. So the point of this isn't we're going to write too many notes, but it's important to have a discussion about these different types of graphs and how to properly set them out. In this one we've got a frequency table, but we've also extended upon that to a percentage frequency table. First thing on the left hand side is we typically have an interval when it comes to numerical data. You'll notice there it says 0 to blank, 10 to blank, 20 to blank, 30 to blank. So those are our intervals on the left hand side there. Essentially what that means is it goes 0 up to 10 but not quite including 10. 10 up to 20 but not including 20. 20 up to 30 not including 30. The reason is we say 0 to not 10 or not including 10 is to avoid any confusion. If you had an interval that said 0 to 10 and then 10 to 20, there can be that confusion as to where we actually put 10. What interval does it fit into? So here, if we did have, say, the number of 10, that would go in the second interval there from 10 up to 20 or just under 20. So you've got 6 people, or depending on whatever the data is, 6 counted between 0 and 10, 14 between 10 and 20, 8 between 20 and 30, and 2 between 30 and 40 for a grand total of 30. That's our total frequency. With percentage, what we do is we take the frequency and convert it into a percentage relative to the total of frequency. So for the first one there, because there are 6 fitting into that interval out of a total of 30, that represents 20% of the data. And that's how you calculate the percentage frequency there. 6 over 30, so whatever the frequency is over the total frequency. We calculate the next one. There's 14 out of 30, which equates to 47% once rounded. Do the same. 8 out of 30 times 100 is 27%. And the last one, 2 out of 30, equating to 7%. So as long as it's done correct, your percentage frequency should total to 100%. This one actually does add up to 101. That's purely because I have rounded. So sometimes if you're rounding, it might add to 99 or 101. That's fine. That's not incorrect. As long as you're rounding correctly. So that's what we have for a percentage frequency table. Now with the histogram, again, we should be pretty familiar with these. On the left-hand side there, we have a frequency table. Same sort of structure as the one on the previous slide, where you got 0 up to 10, and 10 up to 20, 20 up to 30, and 30 up to 40, and that's represented by the histogram there. So a couple of key features of the histogram. Should already be somewhat familiar with these, but I'll just quickly recap. You can notice here that the bars are all touching each other. That allows us to more quickly and closely analyze the distribution. You've got the frequency on the left-hand side. So when you're drawing up your axis, make sure the spacing is consistent. So there's the same gap here between 0 and 2, and 2 to 4, and 4 to 6, and 6 to 8. It's also labeled frequency, so you must label your axes. On the bottom there, the context of this is score, so we put score, depending on whatever the data is, that needs to be labelled on the x-axis there, down the bottom. If this was a really good histogram, it would have a title, but that's missing, so make sure you have a title as well. So that's a nice histogram there. Now, down the bottom, we've got some pictures. I will get you to draw these in your book, to copy those 3 out, where it says symmetrical, positively skewed, and negatively skewed. So I'll give you a moment to do that. If the teacher can just pause the video here to give you time to copy those 3. You'll notice with positively skewed how it sort of trails out to the right. Negatively skewed, it trails out to the left. And with symmetrical, typically the data is more bunched in the middle. It doesn't have to be perfectly symmetrical, but you can clearly see with that example there that the data peaks in the middle. Positively, it peaks on the left. Negatively, it peaks on the right. If we have a histogram that doesn't fit into any of these categories, so it peaks and then it goes down, then peaks again, then goes down again, it's all over the shop, we just say there's no distribution there. So this refers to its distribution, symmetrical, positively or negatively skewed. And please feel free to pause the video at any time if necessary. So the next one we looked at was the stem and leaf plot. Again, underneath symmetrical, positively skewed and negatively skewed. I'll get you to copy out an example of each of those stem and leaf plots there that you can see on the right hand side. Again, we should be pretty familiar with these. We've seen them before several times, but a quick recap. The stem represents, well, it depends on the context of the data. In this case, it's the tens units, whereas the leaves are the leaves are the units. So there's also a key there. So 2 line 4 means 24. So the numbers in this stem plot, the top where it goes 0, then 1, that's just 1, and then 3. On the next line, you got 12, 15, 19, then 21, 24, 26, 27, and then 30 and 34. And again, you can analyze the distribution there, being symmetrical, positively skewed, or negatively skewed. A couple of things about stem and leaf plots. The data must be ordered, so it goes from lowest to highest. And when drawing it, you need to be careful to make it as neat as possible. You notice with the example here, each column of data lines up perfectly. So that 1, 2, then 1, then 0, that all lines up nicely. 3, 5, 4, 4, that all lines up. Then the 9 and the 6, then the 7, they all line up nicely. That allows us to closely analyze this distribution. And the last graph that I want to talk about is a dot plot. I don't have much else here except for what you can see. Pretty straightforward graph. The dots represent the frequencies. So we've got 2 dots above 1 representing a frequency of 2, 4 above the 2 representing a frequency of 4, etc. So pretty straightforward graph. Again, you can analyze this distribution. If it peaks in the middle, it's symmetrical. If it peaks on the left, it's positively skewed. If it peaks on the right, it's negatively skewed, just like the histograms. All right, what I'm going to get you guys to quickly do is a quick activity. Here you've got some data, so you've got 20 values there. What I would like you guys to do is to construct a percentage frequency table like we showed on one of the first slides with intervals of 10, so 0 up to 10, 10 to 20, 20 to 30, and 30 to 40. So on your left hand, you'll have your intervals, in the middle, your frequencies, and then on the right, you will have the percentage frequencies like we looked at in that first slide. All right. Once you've drawn that up, I want you to then convert it into a histogram. So you can write this in your books. Make sure your histogram is really, really neat. Take your time on it. Don't just rush it and do a really sloppy axis. Make sure your spacing is neat and consistent. Use a ruler if you've got one. I'll give you guys 5 or 10 minutes, depending on how long you need. If you need a little bit longer, that's completely fine. If you could now look at the data and have a go at that. So could you please pause the video now and then play it once you're ready for the solutions. All right, so hopefully you've had a chance to have a go at it. This is what your percentage frequency table should look like, something like this. So on the left hand, you've got your intervals there. Frequencies down the middle, so it should have been 2, 8, 5, 4, and 1 for a total of 20. And then the corresponding frequencies. So 2 out of 20 equates to 10%. Then the next one, 8 out of 20, 40%. 5 out of 20, 25%. And then 20% and 5%. And again, it should equate to a total of 100% as long as you've done it correctly. And then the corresponding histogram should look something like this. If you've gone, say, 0, 1, 2, 3, 4, 5, 6, 7, 8, rather than up by 2s, that's completely fine, as long as your spacing is consistent. This one is slightly incomplete. It should have a title on the x-axis. So add that in if you haven't already. There isn't really any context to this data, but it's still good to have a label. So on your x-axis, if you don't have anything labeled, just write data for this. But you know, if it's scores in a sport, you'd write that. And then a title as well. You can just call this one histogram. All right, guys, that's it from me. You can now have a crack at the exercise listed in the lesson plan. Good luck. If there's any questions you're not too sure how to do, skip them and we can come back to them next lesson.